Welcome back to another computer design and manufacturing session, ME8691. Today we are going to see the fourth unit, fundamentals of CNC and part programming. The machine tool is manually operated. The operator controls the relative motion of the workpiece and tool. Normally, the machine tool is operated by the human operator manually, and the human operator moves the workpiece and tool manually. The operator has to perform some functions like starting the machine, stopping the machine, and turning the coolant on and turning the coolant off. With the manual control, the workpiece quality and accuracy is limited, and the time required to manufacture depends on the skill, concentration, and experience of the operator. So it takes more time consumption to produce a particular object. These manual operated machines or increase the errors in the workpiece. When we are using the automatic machine tools, it is used to minimize the errors and variable quality of manual operation. This electronic system converts these numerical commands into the physical movement of the machine tools. Nowadays, these numerical control machines are modified into different machines as follows, like the special purpose CNC machine tool with the vertical and horizontal machining center, flexible machine tools, gear cutting machines, electro discharge machines with CNC, and CMM, which is called as a coordinate measuring machine. So first we should know what is numerical control. The program which is used to perform some actions within the automation machine, which is controlled by the means of coded numbers, letters, and other symbols. That is called as numerical control. So this code numbers, letters, and symbols are control the program and also the automatic machine. The numerical data which is required for producing a part is maintained on punch tape. The data is arranged in the form of blocks of information. This block contains cutting speed, feed, dimensional information, and contour form. So normally there's a block which is used to which is having a more number of informations related to the product which we are going to develop. So to develop the product with good accuracy and good quality, we are going to do the cutting speed, feed, and dimensional. We have to know about the cutting speed, feed, dimensional information related to the particular object. So this is the numerical control. In the first diagram, the procedure of production through numerical control. In the second diagram, elements of NC machine. So first, NC is nothing but it's a numerical control. So first, we should know about the procedure. We are going to find out the procedure of production through numerical control. Okay, there is the first initiation which is from the engineering drawing. So after the completion of drawing or design of a particular product, we are going to plan some process. How we are going to develop a project or product as which we are drawn already or designed already of the product. So we are going to planning the manufacturing process or working process. So we are choosing, there are two ways. One is computer assisted part programming or manual part programming. So we can able to choose any one, like one is computer assisted part programming or manual part programming. Okay, suppose we are choosing the manual part programming or computer assisted part programming, which is called as a CAPP. Both are moving to the tape preparation. So after the development of the part programming related to manually or computer assisted, the afterwards of the part programming creation, it moves to the tape preparation. From the tape preparation only, it moves to the numerical control machine tool, and finally the product will be developed with the help of the numerical control machine tool. Okay, now we are moving to the elements of the numerical control. There are three main elements. One is machine control unit, second one is machine tool and numerical control tooling, and the third one is part program and drawings. So first one is here in the diagram. In the diagram, there's a part program and the machine control unit and machine tool. So the part program which is insisted to the machine control unit, this machine control unit perform with the help of the operation is going to insisted the machine tools to perform the operations to make a particular object with the help of this part program. Okay, now the NC system, which is called as numerical control system, which is classified according to the tool positioning or modes of program. In tool positioning or modes of program, there are two different classifications. One is absolute system and another one is incremental system. And the second one, this numerical control system classified with the motion control system. There are three different types. One is point-to-point system, straight line or straight cut system, continuous or contouring path system. The third one is servo control system. One is open loop system and another one is closed loop system. And the fourth one is the types of feedback devices. One is analog transducer and another one is digital transducer. First one is according to tool positioning. Tool positioning, when we are going to see about the absolute system, all the positions are indicated from a reference. All the positions are indicated from the reference point, which is fixed 0 point or set point, which is fixed 0 point or set point. So here in absolute system, all the positions are indicated from the 0, 0, this is A point to the next level, next end points. Likewise, incremental system, the main disadvantage of this system, if an error occurs into dimensions at any location, all the locations marked after that will carry the same error. So here we are not indicating the or setting the reference point, but if the dimensions are mentioned from one point, it will continue at that point to the next point. But in absolute system, all the dimensions are mentioned from the reference point. Okay, first now we are going to compare the absolute system and incremental system. In absolute positioning system, in this system, all the positions are indicated from a reference point, which is fixed 0 point or set point. But in incremental system, the tool positions are indicated with respect to previous point. In absolute system, it refers from the indicated point or reference point. In incremental positioning system, it indicated from the previous point. In absolute positioning system, the coordinates of each point are independent to one another, or independent to each other. In incremental point, the coordinate points are dependent each other. It depends on the previous points. or the continuity point. In absolute position system, if an error occurs in the dimensions of any location, then the error will be restricted to that location only, because we are setting the reference point or indicated point at 0,0. So if any error occurs in a particular area, the error will not spread. This error will be reduced to the particular point. But in incremental system, if any error occurs at any location of the area of the product, it will continue to the next process also, or next area also. So this is the main advantage in this incremental system. Okay, in absolute position system, a reference point is must. Here, in incremental position system, there is no need of a reference point. Then the next one is according to motion control system. Here the tool is accurately located at some specified point. The spindle is first brought to the starting point, then moved to the next location. On that location, drilling operation is performed, then the tool moves to the next location. If the drill is completed, drilling hole is completed at any particular location, it moves to the next location depending of the starting point. Then straight line or straight cut system. In this system, the cutting tool can be moved along a straight line only. Here, the cutting tool moves along the straight line only, or it depends on the axis of the component. It is not possible to combine the motion axis, hence the tool motion is only along with the x-axis, y-axis and z-axis. And next one is continuous or contouring path system. In this system, the relative motion between tool and workpiece during the whole operation. Due to this relative motion, different curves and profiles can be cut. It is a combination of PTP or straight cut system. Then the next one is servo control system. This system is related with open loop system and closed loop system. Here, first one is main. The input will be given to the main control unit. This main control unit then gives the signals to the amplifier. This amplifier amplifies the signals and move it to the servo motor. Then this motor gives the power to the numerical control machine tool. So there is no need of feedback or closed loop system. It will be give the feedback after the completion of the machine tool. Okay, here the same component, closed loop system, input given to the main control unit, and power or signals given to the comparator. This comparator gives the feedback again to the main control unit, and then it moves the corrected signals or signals to the comparator, and then it moves to the amplifier, and it moves to the servo motor, and moves to the signals move to the machine tool, and after that the output will be moved to the transducer. If there is any correction, if this transducer gives the feedback to the comparator, and if any correction, it moves to the main control unit, and then it corrects it itself, and it moves back to the entire feedback loop. So here there's the open loop and closed loop comparison. Here in open loop system, the feeding of tape, interpretation of information by tape reader, storing the data in buffer storage, converting it into an electrical signal and sending this signal to the control unit. In closed loop system, additional feedback device along with the transducer accompanied by a comparator. It is a simpler and cheaper system. Open loop system is a simpler and cheaper system, but closed loop system is a complicated one, and it is costly than the open loop system. Then feedback device is absent in the open loop system. It is present in the closed loop system, and that if with no feedback device, chance of error is always present. As the comparator compares obtained slide motion, chance of error is greatly reduced. According to the feedback devices, A comparing mechanism is always needed to compare actual slide position with applied slide position to ensure accuracy. Feedback devices or units which convey the actual slide position to the control unit, so the comparison is easily done. So there are two different types of transducers. One is analog transducer and another one is digital transducer. With the help of analog transducer, it produces a variable electric voltage, which varies the rotational speed of the shaft, and it is easily measured and converted into a linear distance to indicate the machine tool position. Likewise, in digital transducer, it converts the rotary motion of a machine screw into a countable electrical pulses, and the number of electrical pulses indicates the linear distance moved by the machine table corresponding to the lead screw motion. And there are so many advantages in this numerical control system. It produces high productivity and less number of wastages, or called as scrap. Reduce the usage of jigs and fixes, and it produces the high quality product. And this numerical control system has a flexibility in the design, utilization of manpower, and reduction in the inventory, safety to the operator and machine tool. There is a great flexibility in the manufacturing. Less floor space is required for this numerical control system, as no jigs and fixes are required, hence tooling cost is also very low. And the main thing here is the skilled operator is not required. The main disadvantages of numerical control system: initial investment is very high. And maintenance is costly and complicated. Costly control systems are also costly. And for part programming, well-trained and highly skilled operator is required. As only one operator is required, there is increase in unemployment. So, applications of ANC system. Numerical control system is used where 100% inspection is required. So, it is suitable for machining of parts where frequent changes in design occurs. Production of precise parts in small and medium-sized production can be done in numerical control system. When accuracy requirement is high, numerical control system is suitable. When a high amount of material is to be removed, numerical control system is preferred. For complex machining operations also, numerical control system is required. Okay, thank you for listening to this topic of numerical control systems in the 4th unit. Let's see the next topics in the next video. Thank you.